Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so check out Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. Go to pythonpodcast.com/linode today to get a $20 credit and launch a new server in under a minute. And to keep track of how your team is progressing on building new features and squashing bugs, you need a project management system designed by software engineers for software engineers. Clubhouse lets you craft a workflow that fits your style, including per-team tasks, cross-project epics, a large suite of pre-built integrations, and a simple API for crafting your own. Podcast.init listeners get 2 months free on any plan by going to pythonpodcast.com/clubhouse today and signing up for a free trial. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the newsletter, and read the show notes. And keep the conversation going at pythonpodcast.com/chat. Registration for PyCon US, the largest annual gathering across the community, is open now, so don't forget to get your ticket and I'll see you there. Your host as usual is Tobias Macy, and today I'm interviewing Julien Danjou about Gnocchi, an open source time series database built to handle large volumes of system metrics. So Julien, could you start by introducing yourself?
Sure. So I'm a software engineer. I work at Red Hat presently. And I stumbled upon OpenStack a while ago, like 7 years ago now. And I've been doing Python for more than 10 years, I guess, more than 10 years now. I wrote a couple of books about it too, and I've been to open source for 20 years. So that's mainly what I do every day.
And do you remember how you first got introduced to Python?
I think it was, 10 years ago. I actually was doing Perl programming, which is not related at all. But I wanted to start doing object-oriented programming, which is something I never get to understand in Perl. It's weird. So I just bought a Nori book. Like I wanted to learn Python, so that's only like a good idea. And I read the book, but at that time I had like no project to write or anything. So I just read the book and thought it would be a good idea to start at some point. And like a year later, I've been a Debian developer for more than 15 years too, and I found an idea of a project, like a build demand for Debian packages. There was something existing in Perl. It was pretty bad, and I decided to rewrite it in Python. So that was my first project.
And so now you've been working on the Gnocchi project. So I'm wondering if you can just describe a bit about what it is and how the project first got started.
So it started like more than 4 years ago. So when I started to do OpenStack stuff, like 7 years ago, the company I worked in was trying to build a public cloud, and there was nothing to build basically for whatever people were using in the cloud. So we had to measure resources that were being used by the different customers, and that made us create the Scalable project. That initial project was trying to do two things, which is what something like Prometheus does nowadays, which is collecting metrics and storing them. So Scalable was pretty good at collecting metrics, but it was pretty bad at storing them. To a point, it was barely usable. I mean, you could store metrics, but you would not be able to query them in a timely manner. Like it would take 20 minutes to retrieve any kind of interesting metrics, which is not something that we call usable. So we stopped focusing on the storage part of Scalable, and I decided to start a new project. So it was just a proof of concept at the start, really just a few lines of Python to show what we could do to store metrics at scale. And in I would say a year, we started to really write and build what is Gnocchi today, which is a time series database. So what it does is that it stores time series, which are a list of timestamp and values for anything that you want. Usually, people use Gnocchi for metrics around monitoring, around infrastructure, but you could use it for any kind of other purpose.
And when it first started, it was housed under the umbrella of the OpenStack project, but it has recently been spun out to be its own top-level project. And so I'm wondering what the motivation was for that and what was involved in separating Gnocchi from OpenStack.
Yeah, so what happened is that when we built Gnocchi, and I think from day one, we had a different view on what we should do in terms of reusability of Gnocchi. Like most of the OpenStack projects were built with the idea that you would need OpenStack to do OpenStack, like any service in OpenStack would need another service in OpenStack, which sometimes makes sense, but sometimes does not. The ecosystem was very close on itself, like we were using only OpenStack library, etc. And we were willing to play the wider ecosystem game and to be a good Python citizen and use like standard library and do things in a way that Gnocchi could be used for anything that is not especially OpenStack specific, even if it could be an OpenStack project and an OpenStack like good citizen. So we thought a bit differently about the project and the way we built it, which after a couple of years made Gnocchi be able to be deployed as a standalone Jamster database in the same way you could use like, I don't know, MySQL or whatever to store your relational data. You could use Gnocchi to store your Jamseries. So that was the first technical point that made us think we could actually move out of OpenStack. And what made us move out of OpenStack is a couple of reasons. Being we wanted to extend our reach. OpenStack was kind of a burden for us because they had a ton of bureaucracy that we didn't want to feel because it was just a waste of time for us. They use a great platform to contribute, like they're based on Gerrit, on Zool for the CI, things like that, which is really powerful and really amazing when you use it every day. The problem is the barrier of entry is pretty high. So if you want to have your user basically something a simple patch, it's going to be pretty hard for them to get on board of the workflow that is used on OpenStack. So on the other hand, you know that GitHub, for example, or GitLab, everybody knows how to use that. It's pretty easy for anyone, even a random contributor, to come and say, oh, I fixed a typo here, here's a pull request. So we wanted to have that happen. We wanted to have a wider community, which is not only an OpenStack one. So we decided to move out of the organization.
And so the space of time series databases and metrics platforms are fairly crowded. So I'm wondering what the unique features of Gnocchi are that would lead someone to choose that over some of the other options, such as Prometheus that you mentioned, or Graphite in the Python space, or services such as Datadog.
So when we started, the space was not that crowded actually. 4 or 5 years ago, there was not a lot of solutions. So when we started, we had a few constraints, being in OpenStack, you can't use any kind of technology. Like, for example, people suggested that we used Hadoop back then to store all of the metrics we were collecting. But there was no way that any OpenStack operator was going to deploy a Hadoop cluster just for storing metrics, whereas the rest of the architecture is based on RabbitMQ and MySQL. So we had to take those constraints in account to build our solution and to not reuse something that was existing back then, but there was not a lot of projects. We built Gnocchi with these constraints and a few other being we were in the OpenStack cloud platform solution where everything supposedly scales out, so you can add any number of nodes in your cloud and it still works. If you need more capacity, you just add more nodes. And we wanted to have that in Gnocchi to store metrics at scale. That's not something that you can find even today in most open source solutions like Influx or Prometheus. You can't scale out that way. I mean, you have to either shard your data or find another way to scale out horizontally. Whereas Gnocchi does that naturally. I mean, if your data storage scales, if you use something like Ceph or S3 or OpenStack Swift to store your metrics, you can scale and add any number of new nodes for Gnocchi, and it will just continue working, and that's all. Another feature that we have in Gnocchi by default, and that's a trade-off. I mean, if you look at all the solutions that exist out there, I was mentioning Influx, Prometheus, or anything based on Cassandra or things like that, they all work differently because when you try to solve this problem of time series, you have to do trade-offs. So we all make different kind of trade-off, and the trade-off that Gnocchi made that you won't find in something like Influx or Prometheus is that we don't store the raw data point. So everything in Gnocchi is aggregated. So if you store metrics, you have to define and to know in advance how you want to store those metrics. Do you want to keep the minimum, the maximum, the average, or do you want to keep only the 90 percentile or things like that? And for how long and for with which granularity, like every 5 minutes, every hour. You have to know that in advance, configure it, and then Gnocchi will work and aggregate everything and won't store your raw data points, which is a trade-off and something that is not the case in what people see usually in timeseries database.
And as you mentioned, the fact that everything is aggregated, that might potentially drive some people away because they may want to have access to the raw data points for some other analysis. And when I was reading through the documentation, I noticed that the raw metrics themselves are actually staged in one storage area before they're then processed by the metrics daemon to perform those aggregations. So I'm curious if there's any sort of lifecycle rules that you can set up to keep those raw metrics around for some period of time or ship them off to another system easily for processing in a different way that is unaggregated.
Right, so there's nothing to move those data points out there, but we've seen people building different kind of architecture, like sending the data points on a bus, like AMQP or something, and plugging Gnocchi and another system on top of that to have two data store doing different things. What was the other part of the question? As for lifecycle, you actually can configure the lifecycle of the archive policy, and you can change that. So if you want to keep your metrics for a longer period, you can do that, and you can change that dynamically. If you really want to store raw metrics, you can do that in Gnocchi. But there's a couple of, I would say, hack that you can use. Usually, you don't poll for metrics every nanoseconds. Usually, you do that every 5 seconds or every second if you do something that is really fine grained. And you can configure archive policy which are that precise. So if you configure Gnocchi to say, oh, I want to keep a data point every second, and you send a data point every second or every 5 seconds, whatever, it will keep anywhere this kind of granularity. So you will lose the precision. Basically, you will lose the timestamp. If it's precise to the microsecond, you will lose that precision. It will be rounded to the second, but you can do that still. And that covers most of the use cases we've seen in monitoring and keeping long-term the metrics.
And what are some of the trade offs of having all of the metrics that are collected pre aggregated before they're queried in terms of the benefits that it provides, and some cases where it would actually be beneficial to keep those raw metrics around for maybe being able to do some more fine grained analysis of events as they're coming in?
Yeah, so having the raw data usually is pretty cool if you want to match timestamps. Like if you have a system that can be very precise, like up to the micro nanoseconds, and you have events that can be correlated this way, you usually want to keep that. But it's less true for metrics than it is for events, which is a different things and a different kind of system. Then the perk of having the aggregation being done before and being done on the fly and store as is that when you query Gnocchi, it's very fast. What it does in summary when you query it is that it looks up the metrics in an index, which is usually a SQL database, and then it just fetches the file on your distributed file storage and just unserialize it and send it back to you. So it's very fast to like get the data, display any kind of charts. Whereas if you want to do some kind of dynamic aggregation, you can do that also with Gnocchi if you want to do more complicated aggregation. But usually if you use something like Prometheus or Influx or whatever, they have to retrieve the data and then compute and then reply back to you with the answer. And it takes sometimes a lot of time.
And can you give a bit more detail on how the Gnocchi database is architected and how that design has changed since you first began working on it?
Right. So the first version of Gnocchi was just like a single daemon with a REST API, and everything was synchronous. So it was working, but very slow. Like you would post on your metrics and we would write the file, compute everything, and that reply back to you, oh, it's okay. So it changed a lot since then. We have like two main components, which is the API. So Gnocchi entry point is a REST API within Python that you can use to store and to read the metric back and communicate with Gnocchi in general. That API, when you send new metrics to it, as you said, it's going to store in a incoming buffer We usually use Redis for that, but there are a number of drivers that we can use, being any kind of storage, be a file or anything. Redis is pretty fast, so we use that usually, and it scales pretty well. Once it's stored in the incoming buffer, there's a second daemon, which we call metric D, for metric daemon. So metric D collects those incoming metrics, aggregates them, and then store them for archiving purpose, let's say, into the final storage. So that final storage is supposedly a scalable storage. So we advise to use Ceph, the distributed file system. I mean, object storage more than file system. But it also works with a file if you don't really want to scale and you have simple ISO if you want to use an FS. We have some users doing that. And it also supports Amazon S3 and OpenStack Swift for object storage. So once the metrics are read from the incoming buffer, we store on that. And the last piece of the architecture is the SQL database. So that's what we call the indexer. The indexer is actually indexing. So it's pretty cool to store timestamp and values, but it's not enough because then you need a way to retrieve what kind of time series you want. Like usually you have a name or something to identify the time series, and you want to look that up when you are looking for a metric for a computer or anything. So we store all of those metadata information in a SQL database because it's pretty fast and easy to query. So that's what we use.
And your point about naming the metrics brings up one of the common issues I've seen in systems that are designed for capturing system metrics is the cardinality of those metrics. And some systems use tagging nomenclature for being able to add additional metadata to make those metrics easier to discover and analyze and aggregate with other systems within a given environment, or for being able to investigate aspects of a particular process. So I'm curious how Gnocchi handles the high cardinality problem and any type of support that it has for tagging metrics and the overall way that those metrics are architected and searched upon.
Right, that's something that people usually ask, like, do you support tags or things like that? And no, we don't. If you look at systems that support those kind of tags, it's pretty hard to support at scale. If you look how to store like EAV in SQL, so like basically attribute value for entities, it's pretty hard to do that in a scalable way. We actually tried in another project in Cinemeter and we just failed because you can do that, but at a certain scale, it's going to be very, very slow. So we decided to not support that. What we implemented instead is a more dynamic kind of schema and resources. So what you can do in Gnocchi, that's another aspect of the software, which is not directly related to the time series, is that you can describe your, I would say, resources, maybe not architecture, but it's resources. So for example, you want to measure the CPU time and the memory usage of a VM, an instance running. What you do in Gnocchi is that you create a schema and you say, okay, so I have a set of resources which are instances. They are a few attributes which are strings, like their name, the host they're running to, they're running on, and things like that. And name of the metrics they will have, like the CPU time, memory usage, etc. So you create this schema, and when you create a new VM, you create a new resource in Gnocchi saying, okay, I have a new VM that just started at that time. That's its name, that's the computer is running to, and that's the metrics I want to store for it. And then you can use that information that is stored into the index to query Gnocchi and to find back the resource that you just created. Usually, these schema are created using the REST API, so you can add a number of fields that you want. You can use strings to describe whatever you want, and you can use that to query Gnocchi and the index behind. So it's way better and easier to make that scale because it's not free form like tags or any kind of EAV that you would implement. But it also makes it very easy to find back any kind of resource that you want to store in Gnocchi and the metrics they have, because it's usually pretty easy to describe the resources. Like the power that you have with the free form of tags or any kind of metadata which are not schematized is really powerful. But in the end, you know that if you want your data to be usable, you have to define and have and use some structure.
And for those resources, That's definitely very useful, particularly in modern cloud environments or container-based environments where these resources may be coming and going very frequently or rapidly. And so I'm wondering how those resource attributes are structured in terms of, is there the capacity to query for all metrics with a given resource type attributed to them, for being able to query across multiple different VMs of a particular type, and then also segment based on specific VMs for doing more fine-grained analysis of events that happened within the lifespan of that one machine, and how the metrics are associated with a given resource as they're delivered into the system.
Yeah, so basically what we did is that we defined like every project you have to do that at some point. We wrote a GSL, a domain-specific language that we offer and provide through the REST API that allows to do any kind of query. And we translate those query to SQL at the end because that's what we use for our index. So you can do any kind of query that you just described, like being limited to a certain time span, to a certain type of resource, to a certain type of host name. If you want to like find your instances running on any particular host name at that time, you can do that and then go to the metrics. There's a full language that we do extend regularly because people keep coming up with new use cases that we didn't think about or that the language is too limited to do. So we just add more feature from time to time to the REST API to cover all of these new use cases. We also implemented Grafana plugin like a year, maybe 2 years ago now, and that also created a lot of new use cases. I mean, I think that was the first big use cases we had to display all kind of fancy dashboard people want. So you have to be able to run a lot of different type of queries. So we added a few extension to the API to cover this kind of use cases.
And in terms of the project itself, I'm wondering what the motivation was for implementing it in Python and whether you would make that same choice today if you were to start over from scratch.
So we never thought about picking another language because being in the OpenStack ecosystem, you had no choice. It was Python or nothing. There are people actually would try to bring Go on the table in OpenStack, and that was a big debate. So we just had no choice. I think today I would keep Python for its ecosystem, which is really great. Like I mean, the code base of Gnocchi is pretty small because we use a ton of library and we actually contribute to library we use because we are very lazy and we don't want to always reinvent the wheel, and we're a small team, so we can't afford to write everything from scratch. So that's something that I do love in Python. The only downside right now for us in Python are the performances. So it's okay because we use NumPy, which is pretty fast. We try to optimize even at some point with Python, a few things, but it was not worth it, so we didn't do it. And Python, I mean C Python at least, performances are getting better every year or so. So I don't think that's limiting us in no, none of our users complain about the performances because of Python. Like most of the performances bottleneck we had were because of what we did and not because of the language or the VM Python itself. I say probably Go is a good pick right now, and there are a few projects in Go, but I'm still think that Python is a good pick for this kind of project.
And one of the other aspects of the Gnocchi system is that it supports multi-tenancy. So I'm wondering how that is implemented at the project layer and some of the benefits that provides for somebody who might not necessarily have multiple customers, but maybe has multiple environments that they're capturing metrics from.
Right. So that's one of the trade-off we had to do when we started to build Gnocchi. OpenStack being multi-tenant, we had to find a time-series database that was multi-tenant, which did not exist 4 years ago, and I don't think still exists if you look at the mainstream time-series database. So the way it's implemented, it's completely on the side of the REST API, where you have a segregation of the metrics and the resources. There's a RBAC policy that is implemented that you can define, and it's actually pluggable. So a lot of the things we do in Gnocchi are pluggable, like the drivers to store the metrics or the index, and even for authentication and authorization, everything is pluggable. So you can write your own plugin in Python. It's we have a few plugins that support like HTTP auth or Keystone auth or things like that. It's pretty easy to write, not a lot of code to write, and you can add any kind of support to your authentication system and how to find your users and how to define which metrics belongs to which users pretty easily. The upside of doing that, and that's something we did in the OpenStack ecosystem, is that then you can give permission to your users to access your metrics. So if you take a case that we know well, which is a public cloud where you have multiple tenants using the cloud, you have a central system like Cinometer or CollectD or whatever, collecting your metrics and storing them into Gnocchi. But in some cases, you'd like to give read access to those metrics. If you don't have any multi-tenant system, then you know that your database is only going to be owned by you and yourself, and you're not going to share it with your users. In the case of Gnocchi, you can give access to the metrics you collected for your users. They can get access to it, read it, and use it.
And for somebody who's interested in deploying Gnocchi to their own system, I'm wondering what's involved in getting it set up and any capabilities built into the system to support ongoing maintenance and upgrades, and also the ways that it can be managed using some sort of configuration management platform for being able to ensure consistent deployments across environments, or just for being able to test and validate before you go to production.
I don't think that's a strong point for us right now. So there are, I would say, the usual suspect for deploying. Like there are Puppet code that exists that is maintained to deploy Gnocchi or recipes like that. We don't provide any kind of fancy system in Gnocchi. It's pretty easy to configure in the sense that you just have to have a gnocchi.conf file, and that just makes Gnocchi works. And that file is pretty easy to write and pretty well documented. So once you have that, you can just copy paste that file on every system where you run Gnocchi and run the API or run metricd or both, whatever. So we are, I would say, agnostic in terms of what system you want to use to deploy, scale, or maintain your system. We don't really care about that. We just try to provide something that works out of the box and that is pretty easy to upgrade, which was not always true. I mean, the first version was pretty hard to upgrade because we also did a few change optimization to the file format, so you had to convert and all, but that was like 2 years ago. We don't do that anymore. We have a good file format, which is pretty efficient, so we don't want to change anything in that regard. So the upgrades are pretty seamless, especially because since all the index schema and database is handled by the REST API and by the client side, that it's the user that's going to create the schema, etc. We don't have to care much about the SQL upgrade of the schema or whatever. I mean, it can be done via the REST API when the user wants to change anything. So the upgrade are pretty seamless.
And in terms of delivering metrics to Gnocchi, I know that there's a specific client that you have implemented, but I'm wondering what other types of systems it will easily support receiving metrics from, such as StatsD or CollectD, or I think I read in the documentation that it supports the Prometheus format.
Right. So yeah, we try to be a good citizen and integrate with everything that exists. So I think the first one we created was a StatsD daemon, but the StatsD protocol is pretty bad. So I think it works, but it's not completely supported. I'm not aware of anyone really using that, but theoretically it works. So we have StatsD. One plugin that is used a lot is the CollectD plugin. So it's a plugin for CollectD that you can use to store the metrics collected by CollectD and to store them into Gnocchi. That is being used a lot by telcos or other kind of people using a lot of CollectD. So we provide an SDK that you mentioned, the Gnocchi client. So that's a Python library which only does REST code, but it offers modules and classes that you can use in Python, which is usually easier to use than just REST API calls. And the CollectD client plugin is actually based on that. We support other kind of bigger protocols. We support the Influx protocol, so you can send the same kind of data you would send to Influx to Gnocchi. If you take a look at the Influx ecosystem, there's a software called Telegraph, which is the equivalent of CollectD. it collects metrics from your system and sends that to Influx. So you can configure it to send it to Gnocchi, and Gnocchi will happily store those metrics for you. And last, we have a Prometheus integration. So Prometheus has a feature when they can export the data to another system. Prometheus does not support long-term retention of the metrics. That's not something they are interested in. So they built a system to export the data so you can archive them. So we have an entry point on the API that supports that protocol and can receive the metrics from Prometheus to do the aggregation we were talking about earlier and store the metrics for long-term retention.
Once the data is in Gnocchi, it's not going to do a lot of good unless you can query it and visualize it. And I know you mentioned that there's some support for dashboarding. And I'm wondering, what are some of the other integration points that are available for extending and customizing Gnocchi, and existing integrations that people can take advantage of, such as maybe Grafana or something like that, for being able to visualize the metrics across the system?
As far as I know, the only tool that you can use to display any kind of fancy chart and all is Grafana. So our plugin is pretty complete. It's maintained, it's easy to install, and that's used by a lot of our users, and they seem to be happy with it. Then you can obviously build your own system. I mean, the REST API is fully documented, and like I said, most of the things we provide in Gnocchi are based on a driver system, like the storage, the authentication, the database access, or many points are based on extension that you can have in Python and in Gnocchi. So it's pretty easy to extend and to add your own system. We are also open to, I mean, it's a free software, so we're also open to have any kind of new extension available if you want to add your own, obviously.
And so when somebody is evaluating Gnocchi against some of the other time series systems or metrics platforms, I'm wondering when Gnocchi would be the wrong choice and they would be better served by a different platform.
Right. So, like I said, if you want to, if you're not interested into the trade-off that we made, which are like pre-aggregating everything, storing at large scale, things like that, you should not use Gnocchi. You should do something else. But if you are interested into that, it's a pretty good platform. In the case when you need the raw data points being stored for doing any kind of over storage analysis later, that's also not a good pick. So, like I said, most of the platform and Jamstack database that you will find are doing trade-off for you. You just need to be really aware of what you need before jumping into any kind of system, because usually then it's a bit too late to switch if you already have a ton of data stored.
And in terms of building and maintaining the Gnocchi project and the community around it, I'm wondering what you have found to be some of the most interesting and useful lessons learned, as well as some of the biggest challenges that you've faced in the process.
So what we learned is that it's pretty hard to build a community that thrives and scales. We actually I think we're a pretty good product technically, but it's very hard to get your project known and to be heard, especially in that space. I mean, it has grown from barely like a couple of projects there and there to a large ecosystem of time series. I mean, you have a time series database like Prometheus for monitoring. You have timescale DB working on implementing time series on top of PostgreSQL. You have so many projects going on right now, project going based on Cassandra or things like that. It's very hard when you build such a project to be heard and to explain to people that there is no one good project that's going to rule everyone. There are a different set of trade-offs that you have to do and that you have to choose. Like, you're not going to store all of your data into a SQL database, obviously. And you're not going to store everything in MongoDB neither. You, depending on the problem that you have to decide what kind of trade-off you want and what solution is good for you. And that's the same thing for time series database usually. But it's still a young, at least for the general public, I would say it's still a young subject, and people are just getting into that. Probably because we were not storing that such a large amount of metrics years ago, and we are storing more and more metrics as a system evolve. So we need better and bigger system.
And what do you have planned for the future of Gnocchi in terms of any improvements or feature additions? And also, is there any particular type of contribution that would be most useful to you in achieving that vision?
Right. So right now we don't have a lot of. We do have a few feature requests, but not that many. We are still improving the API and adding new use cases for people. We have people using the API to build complex system like billing system or a statistics system, capacity planning or things like that. So they can retrieve any kind of data they want from Gnocchi, but sometimes we can make their life easier by implementing the right call in the API. So we tend to try to do that. We'd love to also evolve the API to something fancier. So the API is a bit old. I mean, that's a version one of the API since the beginning and add a few drawback. We'd love to have something new with GraphQL or something. We started a few discussions about that a while ago, but it didn't move. We also want to improve our integration with our system. So we have Prometheus, we have Influx, but these are barely used right now, and we know there might be some issue there and there. So we'd love to have more users and people testing that, so we can make that work better.
And one of the other capabilities that I know is not currently supported in Gnocchi, but has a third party contribution for being able to achieve it, is the idea of alerting, which can be a critical aspect of a monitoring system. So I'm wondering if you can talk a bit about that.
Right. So that's still a debate among the developers as do we I mean we want to support that, but do we want to build that into Gnocchi or should it be outside Gnocchi? So right now we don't have it just because nobody worked on it and it's a huge task. We have a system in OpenStack that is able to like trigger alarms based on the metrics, threshold, etc., which is called Hey, spelled AODH. It's an OpenStack project and it's used in with Hit, which is another OpenStack project. And both those projects will provide a nifty feature, which is autoscaling. And to do autoscaling, you have to evaluate regularly your alarms and your metrics. That's what A does. And it uses Gnocchi to retrieve the metrics and evaluate that. But that's a really small project and it does not support a lot of features and it's barely maintained upstream. So we tend to think we might need another better solution, especially because A is not very fast. It's pretty slow. I mean, it's an old architecture and all. But we never managed to work on that. So we still don't know if it's a good idea to build that into Gnocchi or on the side of it.
And are there any other aspects of the Gnocchi project or metrics and systems monitoring that we didn't discuss yet, which you think we should cover before we close out the show?
I don't think so. I think we got a pretty good coverage.
So, for anybody who wants to get in touch with you and follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose a podcast that I listen to from NPR called the Marketplace Podcast, which is just a great way to keep up to date with some of the news of the day as it pertains to economics and the overall economy. So it's an interesting podcast, good way to stay up to date. And so with that, I'll pass it to you, Julian. Do you have any picks this week?
I would like to say a word about a new product I work on, which is Mergify. So it's available on mergify.io. So it's an open source engine that helps you merge your pull request in GitHub. And that's actually something that we started to build while moving Gnocchi to GitHub.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you've been up to with Gnocchi. It's definitely an interesting project and one that I've been evaluating for my own use. So after learning a bit more about it, I may end up getting that deployed. So thank you for your work on that. Thank you for your time, and I hope you enjoy the rest of your day.
Thank you, Tobias.